Okay, after many failed attempts, I think I just have to film this. So here's my project. My two envelope functions are f of x equals x minus 3 to the fourth plus 3, and g of x equals cosine 6x plus 8. Okay, to find the intersections necessary to analyze the region, I set them equal to each other, plugged them in the calculator, and found the intersections that way. So they're at x equals 1.585 and x equals 4.481. Okay, here's the integral expression that gives the area of the region. So we have top minus bottom, the integral of top minus bottom. Is it reasonable to compute the area of this region in terms of y? No, it is not, because the inverses of g of x and f of x are not functions on this domain, so therefore the region would have to be chopped up many times in order for the area to be computed. It would be much, much more difficult. Okay, so my cross-section shape is a hexagon, and so the way I figured out the volume is to think about it in terms of 6 triangles. So here's the formula for a triangle, root 3 over 4 times g of x minus f of x squared, and then I just multiplied that by 6. So 3 root 3 over 2 times g minus f squared. And here's that with the expressions plugged in within the region. All right, and a visual is right here. So you can see up top here the functions, and then to see the shape, let's see, okay, there you can see it, the hexagons. Okay. Next is the integral expression that gives the volume of the solid rotated around the x-axis. So here's that, and then here is the visual. So start it over again. Okay, going around the x-axis. So that's what that looks like. Okay, next is I've rotated around a horizontal axis that is above the region. So for this I did x equals 10, and so the small radius in that washer shape would be 10 minus g of x, and the big radius from the top function to the bottom would be 10 minus f of x. So that's the outside radius, and let's see, is it this one? No, it's this one. Okay. So it's rotated around the x-axis, there it goes. Okay, you get the gist. And lastly, rotate it around an axis that's below the region. And I chose x equals 2. So the small radius is f of x minus 2, the big radius is g of x minus 2, and here's that written out. And here it is. Okay, rotated around the x equals 2, or sorry, y equals 2. Okay, and that's it. Thank you.